Assignment 4, preview. In question 1, it says, from statistics grades, John has a mean of 70 with a standard deviation of 15. Jane has a mean of 70 and standard deviation of 5. It says to calculate the 68% range to answer the following questions. So first, describe the two students in terms of consistency of their grades and give reason. The question here is really asking you to compare the two standard deviations between the two students, John and Jane. Obviously, their means are identical, but their standard deviation tells you a little bit more about their actual scores, right? So in terms of consistency, which would be different from or opposite of variation, we're looking for a smaller standard deviation, right? And because a smaller standard deviation would mean more consistency, right? So see if you can answer that question. And the second question is, who is more likely to get a 60 on the next test and why? So when you look at the 68% range that you've calculated for John and calculated for Jane, that 68% range then becomes the majority of the time what their score is going to be within that range. So see if between the two ranges, which student's range contains the score 60, right? Who's more likely to get a 60 on the next exam? And it wouldn't surprise you because it's within the usual range. So look at the 68% range for the two students to answer this question. And question C says, who's more likely to do either extremely well or extremely poorly on the next exam? So who's more likely to fluctuate, right? Whose score is kind of unpredictable, right? So again, you want to look at the standard deviations to answer that question. In question 2, it says, as part of studying the relationship between reported SAT score and recorded SAT score, the following scores are obtained. So these are differences in SAT scores of these students. Question A says, determine the range and describe your answer in words. We know that to determine the range, we have to look at the highest score and look at the lowest score and take the difference. And how you describe the range in words is to say the difference between the highest score and the lowest score is, and give the range, right? So our usual way of talking about what range is. And then in question B, it says, determine the variance using the computational formula and describe your answer in words. So remember that computational formula where we needed a total of all the data points, right? And also a total of all the squared data points, right? Squared numbers. And then putting them into a formula to calculate for the variance. So here you want to create a column of x's and list all the numbers, and they don't have to be in order. But if the numbers repeat, you have to keep them and all the way down. And you also need to square the x's, and then you need the total down here, and then plug them into the computational formula. Now, to describe variance in words is kind of difficult. It kind of doesn't make sense to say the average of square deviations is such, right? So that's really the only way that we can describe variance in words. So use the words average of square deviations in your word description of the variance here. And then in question C, it says, determine the standard deviation using the computational formula and describe your answers in words. So once you have your variance, then we can square root to get your standard deviation. So it's an easy one step from the previous question, question B, to question C. So then the description of the standard deviation is using the words in an earlier slide, you would say on average, scores vary from the mean by, and give the answer. In question 3, it says, if the differences of recorded and reported scores of SAT could be tested for all possible subjects in question 2, what would the following be? Now in this question, it looks like we've already answered this question, but obviously it's looking for something else. The key phrase here is for all possible subjects, right? So that refers to the population. Right? So what is being asked here for variance and standard deviation is to calculate the variance and standard deviation of the estimated population. This calculation is going to be very similar to question 2, but remember, if you're using the computational here, because you've used it in number 2, that makes sense, we just need to add the n-1 in the denominator and then square root. So see if you can use the variance formula, the standard deviation formula for the estimated population. And you'll notice the answers are going to be slightly higher than the answers in question 2 because we're expecting more variations for the entire population. It says to round answers to 2 decimal places in question 4. Here is a frequency table, and you thought you would never see one again, right? Here are the numbers in the X column, and then here's the frequencies. You definitely see that the data is skewed. There's high numbers at the top, and then it would not give you a nice normal distribution there. So this is a skewed data. And it says in the bottom, the scores at the 25th percentile for the above distribution is 28.13. The score at the 75th percentile for the above distribution is 29.97. So to determine the semi-interquartile range for the above data, we recall here from the formula for semi-interquartile range that we want to just take the difference between these 2 scores, or from 75th percentile minus the 25th percentile, right, and take the average of the difference, and that should give you your semi-interquartile range. So in question 5, it says to calculate the variance using the definitional formula of the following scores, and it says to set up a table. So here I have created a table in the making. So we want to list the numbers in the X column, and then we want to subtract the mean of 6 from each score. And when you have your deviation scores, then you want to be able to square them and take the average of square deviations. The question is asking for just a variance, right? So we don't need to square root. Since the question is asking for variance, we don't need to square root, but leave the answer as is.